Hello students, how are you today? This is our second class of physics of class 9. In the first class we had learned about rest and motion and a reference point or point of reference, which is also called the origin. In today's class we are going to learn some other concepts. So see, when a body moves, it may move in a straight line, move in a circular arc, or it may move haphazardly. Out of all these different motions, right now we'll be talking about only the straight line motion. So that is called motion in a straight line. Very simple. When a body moves in a straight line, it's called straight line motion. Now, to describe the motion of a body, different terms are used. One such term is distance. So distance means distance traveled by the body. The body at point O, in 2 hours it moves from here to this point A. Okay? Then we will say the distance traveled by the body is OA. That is the length of OA. Now, if OA is 10 kilometers and the body moves it from here to here in 2 hours, then we will say the distance traveled by the body is 10 kilometers. Simple. Now say in next 1 hour it comes from A to this point B. So say this is 1 kilometer. It comes back in 1 hour. Okay? Then we say the initial position of the body is O. The final position of the body is B. And the distance traveled by the body is OA plus AB. So this is OA plus AB. So this will be 10 kilometers plus 1 kilometer. That means 11 kilometer. Distance covered by this body in 3 hours is from here to here plus here to here. So that will be 11 kilometers. Okay? So the meaning of this word distance in physics and in common use is almost the same. Okay? The next term to describe motion is displacement. Now this word is a new word because this is not used in our common uses. Okay? So let's learn what is displacement. Now the displacement is defined as the shortest distance between the initial position and the final position. Okay? This is the definition of displacement. Displacement is defined as the shortest distance between the initial position of the body and the final position of the body. Okay? There is one more aspect we have to consider while talking about displacement, that is the direction of the displacement. That I will come to later, but first let us understand what will be the displacement in this case. See, initially the body was here, so this is the initial position of the body, and after 3 hours it is at B, so this is the final position of the body. So the length of OB this will give us the displacement. That means the displacement of the body is OB. Now how much is OB? From here to here, this is 10 kilometers. From here to here, this is 1 kilometer. So this will be 10 minus 1, that is 9 kilometer. Understood? Okay. So in this example, the displacement of the body will be 9 kilometers. What was the distance covered? Distance covered was 11 kilometers. 10 plus 1. That is the actual length of path traveled by the body is the distance, and the shortest distance between initial position and final position, that is the displacement. Okay? To be more precise, 9 kilometer is the magnitude of the displacement. The value of the displacement is called the magnitude. It is the magnitude of the displacement is 9 kilometers. But as I said before, this displacement has a direction also. In other words, a direction is associated with this displacement. The direction of this displacement is from the initial position to the final position. So that means here the direction of the displacement is in this direction, from O to B. Clear? If we have to say completely about displacement in this situation, we will say the displacement of this body is 9 km in the direction of O to B. Okay? Let me take 2-3 more examples to make it clearer to you. Example 1. Say a body has started from O, it has moved in this direction for 4 kilometers. Okay? Then from here it went in this direction. So say this is point A, this is point B, and say this is 3 kilometers. Okay? So the initial position of the body is this. This is the initial position, and the final position of the body is this. Right? So this is the final position. So in this situation, what is the distance traveled by the body and what is the displacement of the body? Let's think about that. Okay? Now see, distance covered in this situation is 4 kilometers plus 3 kilometers. Distance covered is always the length of the actual path traveled by the body. So from here to here, it traveled 4 kilometers. From here to here, it traveled 3 kilometers. So distance is here 7 kilometers, or distance covered is 7 kilometers. Okay? Now what about the displacement? Displacement is the shortest distance between the initial position and the final position. So what is the shortest distance? So if we draw a straight line from here to here, we all know straight line distance is the shortest distance. So this OB, that is the length of this line, that is the shortest path. So that is the value of the displacement. How much will this be? From here, since this is a right angle triangle, we can use Pythagoras theorem. So this will be square root of 4 square plus 3 square. So 4 square plus 3 square, 16 plus 9 is 25, under root is 5. So here the displacement is 5 kilometers. That is the value of the displacement, or the magnitude of the displacement. Okay? What about the direction of the displacement? The direction of the displacement is along OB. Okay? So direction of the displacement is along OB. This way. Understood? This is example 1 to illustrate the difference between distance and displacement. Let's take another example. Example 2. Say body was at O, then it moved this way and reached this point A. This distance is say 8 kilometers. In this situation, we want to know what is the distance traveled and what is the displacement. This is very easy. So distance traveled is length of OA. This will be 8 kilometers. And here, this is the initial position. This is the final position. So displacement is also 8 kilometers along OA. Clear? So in this situation, distance travel is equal to the value of displacement or the magnitude of displacement. Okay? So in simple situations like this, the magnitude of displacement and the distance traveled are equal. Here also it is 8 kilometers. Distance travel is also 8 kilometers. Only difference is that in displacement we have to say this is 8 kilometers along OA. We have to specify the direction. Clear? In the earlier example, that is example 1, we have found that the distance covered was 4 plus 3, 7 kilometers, but the displacement was 5 kilometers. That means the value of the displacement was less than the distance traveled. Now this is always true, that this displacement, when we say displacement is less equal to distance, we mean the value of the displacement, the magnitude of the displacement is always less than or equal to the distance traveled. It cannot be more than this. Displacement may be equal to distance, but it can never be more than distance traveled. Usually, displacement is less than the distance traveled, because displacement is the shortest distance between these 2 points. You should remember this point from exam point of view. Okay, let's take another example. This is example 3. So say a body is here at O, then it moved in a semicircle, so then it reached this point A. So this is a semicircle. The body moved along this direction and the radius of the circle is R. We have to find the distance traveled by the body and the displacement of the body. Okay? Can you give me the answer? Just think. The distance traveled here will be equal to length of this part. How much will be this? Say this is a circular part. This is half of the circumference. The circumference of the circle is twice pi r. Half of that will be divided by 2. That means the distance traveled here is pi r. Length of this part. Okay? And the displacement, this will be equal to distance between the initial position and the final position, the shortest distance. So we can, shortest distance is along the radius. So this is r plus this is r. So displacement will be twice r. Another example. Say the body is at point O. It moved along a circular path and came back to the original point. So it moved along a circular path and stopped again at O. What will be the distance and what will be the displacement? Now see, the distance covered by the body is the circumference of the circle. So circumference of the circle is twice pi r. if r is the radius, what will be the displacement? Displacement is the shortest distance between the initial point and the final point. In this situation, the body initially was at O and it came back again to O, that is its final position is also O. So that means the displacement here is 0. With these 4 examples, I think your concept of distance and displacement is clear, right? Let's see the book, what is there. So I have covered this page 99 in this book, motion along a straight line and the definition of distance and displacement. The total path length covered by the object is the distance covered by the object. The shortest distance measured from the initial to the final position of an object is known as the displacement. There is an activity here. So activity 8.3 says, take a meter scale and a long rope, walk from one corner of a basketball court to its opposite corner along its sides. Measure the distance covered by you and magnitude of the displacement. What difference would you notice between the two in this case? You all know basketball courts are like this. It is a rectangle. So if you are here, this is a starting point. Say you move along this side first, then you move along this side to reach this point. So this is your final position. So distance covered will be this plus this. Say OB plus BA, and the displacement will be this OA. So this is similar to our example 1. Next, there is a question here on the next page, page number 100. So we have 3 questions on page 100. The first question is, an object has moved through a distance. Can it have 0 displacement? If yes, support your answer with an example. This is our example 4. When it moved along the circle and came back to the initial position, its distance was the circumference twice by r, but the displacement was 0. It is not the only example. Say a body can move from here to here, then 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 come back to the original position. In this situation also, the displacement will be 0, but the distance traveled will be this plus this plus this plus this plus this. Okay, so in the exam, either you use this example or use the example of the circle, which is our example 4. Okay. Second question is, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from its initial position? It says the farmer moves along the sides of a square field. So let's say this is a square field of size 10 meters. So this is 10 meters. Say he starts from this point O. To make one round, it takes 40 seconds. Okay. Now we have to find his displacement after 2 minutes 20 seconds. So 2 minutes 20 seconds will be, 2 minutes means 120 seconds plus 20 seconds, that means 140 seconds. Okay. So after 140 seconds, we have to find his position. So see, in 40 seconds, one round. In next 40 seconds, that means in 80 seconds, he will be again here. In 120 seconds, he will again be here. So after 120 seconds, how many seconds are left? 140 minus 120. So 20 seconds are left. So in 20 seconds, you will move from here to this point. Now see, 140 seconds is much more than the 40 second. So that means you will move around the field many times before he stops. Okay? So how many times he will move? We can divide 140 by 40. This will be 3.5. That means he will complete 3.5 round in this 140 seconds. So 3 round means 1 round, 2 rounds, 3 rounds, then half means from here to here. So his final position will be this point, this corner. Okay? So it is asking us what will be the magnitude of displacement. So magnitude of displacement means initial position is this, final position is this. So length of this we have to find out. Now this is a right angle triangle. So it is very simple. We can use Pythagoras theorem. So OA will be equal to square root of this square, it is 10 square, plus this square, this is again 10 square. So this will come out to be square root of 100 plus 100, 200. Right? You can think of it like 2 into 100. So square root of 100 is 10 and this root 2 will remain. So these many meters. Clear? The third question is, which of the following is true for displacement? A. It cannot be 0. This is false because we know displacement can be 0. Right? Because if the final position is same as the initial position, then displacement is 0. So it cannot be 0 is false. B part of the question is, its magnitude is greater than the distance traveled by the object. I have explained before that displacement is always less than or at the most equal to distance. So its magnitude is greater than distance traveled. So it is false. So in this question, it is question number 3, B part is false. Clear? So this is the concept of distance and displacement. I think it is clear to you now. So that's all in today's class. Bye.